In this example, we are going to look at finding the area between a curve and the x-axis. So you're going to need to turn to this booklet, and you're going to need to find this page, and we're going to be making use of this bit of information here, using the idea of integration to figure out the area between a curve and the x-axis. So in particular, we'll make use of limits to try and evaluate what the area is between two values of x, a and b. The furthest right limit is the top limit, or the upper limit, and the furthest left is the lower limit. The example that we're going to do is fairly straightforward, to start with at least. So we are going to try and calculate the area under the graph of y equals 6x squared between x equals 2 and x equals 5. So we start off with this, where the area is given by the integral of 6x squared integrated with respect to x between the limits of 5 and 2. And before we get too far into the example, it is probably worth just putting a little sketch to show exactly what it is we are figuring out there. The graph is fairly straightforward. The graph of y equals 6x squared is just a parabola. And we are interested in finding out the area between the limits of x equals 5 and x equals 2. So we are trying to figure out what this area here is. That's what we are trying to calculate. So, going back to our integrating problem, we're going to integrate 6x squared. So the rule for integrating, of course, is add 1 to power and divide by the new power, which gives us 6x cubed over 3. We can simplify that. Of course, it becomes 2x cubed, and we're going to integrate that between the limits of 5 and 2. So the next step is really straightforward. All we're doing is replacing the x with the upper limit of 5, and from that we're going to subtract what we get when we replace the x with the lower limit of 2 to the power of 3. So it's just a case of evaluating that. 5 cubed, 5 times 5 times 5 is 125. Multiply that by 2, gives us 250. 2 cubed is 8. 2 times 8 is 16. So we get 250, take away 16, which gives us an answer of 234. And we should probably try and put it in a context because the question is asking about area. So we should say that we're talking about units squared. So that's a really straightforward example of using integration to figure out the area between a curve and the x-axis. What you should try and do now is some of these hopefully straightforward questions on exercise 17a, page 353. Questions 1a, c and e, and questions 2a, c and e.